concentration terms. Concentration terms. In second year physical chemistry, this is first part of solutions lesson. Concentration terms and basic concept for other chapters also. Concentration terms are used to, these are used to express weight of solute in solution, weight of solute in solution, amount of solute in solution can be expressed by using concentration terms. Let us take sodium chloride salt. If we hold sodium chloride salt in hand, we can say its weight is some 10 grams or 20 grams like that. After dissolving in water, how can we say? Is it possible? Because it dissolves. We cannot see sodium chloride salt, right? So in that case, we use concentration terms, right? Concentration terms are used to express the weight of solute in solution. Generally, how we will express the weights? Weight is expressed in kilograms, grams, milligrams, like that. But once you dissolve salt in a solvent and after getting solution, you cannot use that units like kg, grams. We have to use concentration terms, right? See the concentration terms. First one, weight percent. Weight percent, it is also represented as small w by capital W. Weight percent. Second one, weight volume percent. Weight volume percent. W by V percent. W by V percent. Third one, molarity. Molarity symbol is capital M. Normality, capital N. And molality, small m. Mole fraction, ppm, parts per million. These are concentration terms. And fundamentals for other physical chemistry chapters like ionic equilibrium, chemical kinetics, chemical equilibrium, ionic equilibrium, thermodynamics. In every physical chapter, all these basics will come. Okay, basics as well as important in stoichiometry and important in solutions chapter also, right? For example, like nomenclature. We'll get a question from nomenclature chapter, and the nomenclature concept is used in other chapters also, right? Can you say anybody? Akshara? Can you give the meaning of this? Just I am checking. What is the meaning of W by W? NaOH aqueous solution. Can you try, Shruti? Can you give its meaning? All are second years only, na? Anybody? Just to give the meaning for that. What is the meaning of that notation? Say whether it is correct or wrong, give one answer, nothing will happen. Any idea, Advait? Akshara? Weight by molecular weight. 10% W by W NaOH solution means, if you know this, you can do the numerical, because sometimes you won't get the data, complete data. Okay, you will get notations like this. That's why I started. Very, very important fundamentals will come in. Weight percent, small w by capital W, weight percent. Numericals related to solutions depends on these weight percent, especially first part of the solution. Okay, see. I am taking 100 grams of solution. 100 grams of solution. Remember, in solution we have two parts: solvent and solute. Solute is present in smaller amounts. Solvent is present in excess amounts. Solute and solvent. Okay. Solute is present in smaller amounts. Solvent is present in larger amounts. Just one small basic point I am giving to you. Right. I am taking 100 grams of the solution. 100 grams of the solution. In this 100 grams of the solution, how much weight is present? How much weight of solute is present? You remember, solution is made up of solute and solvent. Clear? When we dissolve solute in solvent, we will get solution. Clear? If we take 100 grams of solution, in that 100 grams of solution, how much amount of solute is present? That is called as weight percent. The weight of the solute in 100 grams of the solution fixed. 100 grams is fixed. Clear? The weight of the solute present in 100 grams of the solution is called as weight percent. Okay? 100 grams, 100 ml standardization. We have to compare with 100 ml, 100 grams, fixed always. Okay? Write the definition. The weight of the solute. The weight of the solute. The weight of the solute present in 100 grams of the solution. 100 grams of the solution is called as weight percent. Weight of the solute present in 100 grams of the solution is called as weight percent. Okay, right. See the formula for weight percent. Small w by capital W percent is equal to weight of the solute in grams divided by weight of solution in grams into 100 to 100. This is the formula for weight percent. To calculate weight percent, we have to use this formula. Once look at this, all of you. I am taking some 80 grams of water. 80 grams of water. Water is the solvent. Okay. Water is the solvent. And I am dissolving 10 grams of salt in it. 10 grams of salt in it. Then I'll get solution. This is solution. Now you tell me, what is the weight of the solution? Tell me, what is the weight of the solution? What is the weight of the solvent? 80 grams. What is the weight of solute? 10 grams. So mix these two. What you will get? 90. Now you tell me how we are getting weight of the solution? By adding solvent weight plus solute weight. So weight of solution, right? Very important. Weight of solution is equal to weight of solute plus weight of solvent. Basics. All these are basics. Weight of solution is equal to weight of solute plus weight of solvent. notations. Notations. 10% keep symbol important. 10% W by W. NaOH aqueous solution. NaOH aqueous solution. So we have to write the data for this notation. See the meaning for this notation. Here number is there. Number 10, 20%, 30%. This number always represents weight of solute. This number always represents weight of solute. This is solute. What is this? Solute. Whatever it may be the percentage, 20, 10, 30, 40%, this number always represent weight of solute. You will get a name here like Na2CO3 solution, glucose solution. That is only the solute, right? Okay. Now you tell me what is the weight of NaOH? 10 grams. 10 grams. See the meaning for the notation. 10 grams of NaOH is present in 100 grams of the solution. 100 grams of the solution. 100 grams is fixed. Statement always ends with 100 grams. Statement always ends with 100, irrespective of this number, 20, 30, whatever it may be the percentage. For example, if I write 40% W by W NaOH means, guess, 40 grams of NaOH in 100 grams is fixed. Don't change that. Clear? I asked this only. I expected this answer from your side. Clear? Now, develop the data. Weight of NaOH. What is weight of NaOH? Weight of NaOH 10 grams. 10 grams. Clear? Weight of solution. 100 grams. Now you tell me weight of solvent. How we will get weight of solvent? Subtracting solute weight. 100 minus 10, that is 90 grams. Okay. In molality numerical, we use this term, and very, very important. You will get numericals and molality. Molarity, normality, molality. You will get a weight percent. Calculate molality of 10% W by W glucose solution. If you don't know these basics, you cannot do the question. Okay? Right. Writing solvent weight, writing solute weight. Solvent weight is needed to do molality questions. In molality, solvent will come under denominator. Right? Okay. First term is okay for everyone. I will give you another example to you. You do it. 1.8% W by W glucose solution. You write directly weight of the glucose, weight of the solution, and weight of the solvent. Write directly weight of glucose. What is the weight of glucose? 1.8 grams. Weight of solution 100 grams. Then weight of solvent, Subhiya, weight of solvent is 100 minus 1.8. Then how much? 100 minus 1 is 99. Okay. 99 minus 0.8, 98.2. Right. Second concentration term, weight volume. Symbol is W by V. See, one compound data is in weights. This represents weight of solute. Weight of solute. This represent volume of solution. Volume of solution. Next concentration term, weight volume. W by V. W represent weight of solute. V represent volume of solution. Weight volume. I will give you the formula directly. Okay. Instead of definition. Definitions are not useful. Totally time waste only. So write the formula directly and notation. Notation only useful for us. I will give the notation directly. W by V percent is equal to, see the formula, weight of solute by volume of solution. Volume of solution. This is ml, this is grams into 100. So remember the formula, weight volume percent formula. Weight of the solute in grams by volume of the solution in ml into 100. Now coming to the important concept notations. See, 10% W by V Na2CO3 aqueous solution. 10% W by V Na2CO3 aqueous solution. Let us write the meaning or data. Weight of Na2CO3 is equal to 10 grams. Volume of solution is equal to 100 ml. See, 10 grams of Na2CO3 is present in 100 ml of the solution. This is the meaning. In last term we used 100 grams. Now 100 ml because V is there. Got it? 10 grams of Na2CO3 in 100 ml of the solution. Can note down. 10 grams of Na2CO3 is present in 100 ml of the solution. 100 ml is fixed. 100 ml is fixed. Third concentration term, molarity. Molarity. Any idea? Definition of molarity? Okay, see. Let us take 1 liter solution. Let us take 1 liter solution. 1 liter solution, right? And imagine these spheres represent mole. This is 1 mole. This is 1 mole. This is 1 mole. Right? What is the meaning for this? 1 mole means inside the sphere, how many particles will be present? 6.023. I given in the basics. 1 mole of any substance contains 6.023. So inside sphere we have 6.023 into 10 to the power of 23 particles. Okay, these many particles are present. How many? 6.023 into 10 to the power of 23 inside the sphere. Okay, now we are dissolving the sphere in water. How many spheres we dissolved? 3. Each sphere is called as a mole. Why? Inside the sphere, how many particles are present? 6.023. That's why we are calling each sphere as a mole. Now you tell me total how many moles are present? 3. In how much volume?
1 liter.
1 liter.
Solution.
Stress 1 liter solution. Very important. That is also important. Definition also important. 1 liter solution. Number of moles of solute present in 1 liter solution is called as molarity. Number of moles of solute present in 1 liter solution is called as molarity. The number of moles of solute present in 1 liter solution. 1 liter solution is termed as molarity. The number of moles of solute present in 1 liter solution. Let us start the formulas. Important formulas in molarity. First formula, molarity is equal to number of moles by volume in liter. First important formula. Molarity is equal to number of moles by volume in liters. Number of moles by volume in liter. And from this you can write number of moles is equal to molarity into volume in liter. This is expression for number of moles. Number of moles. N. M represents molarity. Clear? Number of millimoles. Number of millimoles is equal to molarity into volume in ml. Molarity into volume in ml. If I ask you, what is the formula for number of moles? Molarity into volume. What is the formula for number of millimoles? Molarity into volume in ml. In place of liter, if you take ml, that is milliliter. Milliliter. How to calculate number of millimoles? By taking volume in ml. For example, volume is given to in liters. Convert it into ml and substitute here. You will get millimoles. Millimoles. Right? Look at this. Find the number of millimoles. Find the number of millimoles in 0.2 molar. 0.2 molar. 5 liter NaOH solution. This is the question. This is fundamental topic for other chapters. That's why I am giving one question on this. Finding the number of millimoles in 0.2 molar 5 liter sodium hydroxide solution. Right. To calculate number of millimoles, volume should be in milliliter, but volume is given in liters. So how to convert? Volume is equal to 5 liter. Convert it into milliliter. 5 into 1000. 5000 ml. Because 1 liter is equal to, these are very important. 1 liter is equal to 1000 ml. I already given this 1000 centimeter cube in the last class. I given 1 ml is equal to 1 centimeter cube. That's why I given 1000 ml is equal to 1000 centimeter cube. Okay, right. Substitute in the formula. Molarity into volume in ml formula. Number of millimoles. Molarity how much given to you? 0.2 into volume is 5000 ml. Then how much we will get? 1000 millimoles are present. So to calculate number of millimoles, multiply molarity with volume in ml. Multiply molarity with volume in ml. To get number of moles, multiply molarity with volume in liter. Volume in liter. Number of moles to number of millimoles. Clear? Right. This is the first formula of molarity. And one important point I will give you. What is the relation between molarity and volume, or concentration and volume? Molarity nothing but concentration term. Inversely proportional. Very important. Molarity is inversely proportional to volume. Mention this. Useful in other chapters. If you increase the volume, then concentration decreases, means molarity decreases. In ionic equilibrium, in chemical equilibrium, we use this. In chemical kinetics, we use this. Okay, right. Let us see other formulas. Second formula. Molarity is equal to, in place of number of moles, what we can write? Number of moles is equal to weight by gram molecular weight. 1000 by volume in ml. This is second formula. By heart the formulas. by next week. Third formula, molarity and density. Molarity is equal to weight percent into 10 into density by gram molecular weight, G and W. All these basics were over in the last two classes. Gram molecular weight. In place of density, you can write specific gravity. D stands for density, or sometimes density is equal to specific gravity also. Specific gravity. If you get a specific gravity or if you get density, use the same formula. Okay, density D is equal to specific gravity, or density D stands for density or specific gravity. Sorry. When specific gravity is given or density is given, use the same formula. Okay. Sometimes see, very easy level questions will come. Direct formula based questions will come. This is also very important formula in that category, density related formula. You will get density, you will get weight percent, then you have to calculate molarity. If you know gram molecular weight, then you will get, otherwise you won't get. What is the gram molecular weight of glucose? 180. 180. You should be very spontaneous in that basics. I already given some important compounds and their weights in the last class one. Right, have you copied this? Next, fourth one. Keep heading, fourth one. Dilution principle. Dilution principle. Dilution principle. Fourth one, dilution principle. What is the meaning of dilution? Dilution means addition of water. Addition of water. Salt or water is called as dilution. Dilution. Look at this. I am taking one solution. Whose initial molarity is 0.1, whose initial volume V1 is equal to some 10 ml. Okay, I am adding 20 ml water to it. Right. Then what happens to the volume? What is the final volume? Tell me. Initially 10 ml is there. We are adding 20 ml. So final volume will become 30 ml. Now my question is how to get the final molarity? Before adding water, molarity is 0.1. After adding water, what is the molarity? Clear? After addition of water, molarity, the concentration decreases. No doubt in that. And what is the exact value after adding water? Before adding water, molarity is 0.1. After adding water, what is the molarity? This is dilution law or dilution principle. By using this formula, we can find the final molarity. Means after addition of water, we will get a molarity. M1 V1 is equal to, very easy, M2 V2. M1 V1 is equal to M2 V2. M1 is initial molarity. V1 initial volume, final molarity and final volume. Final molarity means after addition of water, and we know final volume is easy only. Okay, very low level basics, all these are. Okay, in ionic equilibrium, you know pH calculations. Before addition of water, one solution is having this much pH. After addition of water, what is the pH? We use this fundamental concept only. Ionic equilibrium is very important topic in the first year physical. Molarity only, na? Oh, okay, sorry. No one is observing. Molarity only. By mistake I wrote. R only. R. Capital M represent molarity. Next, keep reading. Dilution principle is okay for everybody. M1 V1 is equal to M2 V2. When we use M1 V1 is equal to M2 V2, when you observe the word water is added, diluted to, diluted up to, diluted up to, water is added. In all that cases we use this. Okay, right. Next, resultant molarity. Fifth one, resultant molarity. Resultant molarity. Within the bracket keep adding M resultant. M resultant. Resultant molarity, M resultant. Shruti, tell me, what is resultant molarity formula after long time? I think you didn't revise, right? First, second year is, I think 2 months before only completed, na, physical for you. Solutions for finished or not? Solutions chapter. Solutions, kinetics. Anybody? Resultant molarity. No idea? Resultant molarity. See why I am asking. If you know that basics very well, then I can skip that. I don't want to waste the time. That's why I'm asking you. If you thorough in that basics, I'll skip and I'll go to other. You should open. If you don't know, I'll explain. Otherwise, you only will get the problem. If you don't know anything, just tell me. I'll teach from the beginning onwards. If you sit silently, then I cannot imagine the situation. Clear? Yeah, yeah. Okay. Correct. Right. Let us take one solution whose molarity is M1, another solution whose molarity is M2. First solution volume is V1, second solution volume is V2. You have two solutions. Now mix the two. You will get new solution, right? What is the molarity of this new solution? How to calculate concentration of this new solution? By using M resultant formula, right? M resultant is used when you mix two different solutions. So different solutions in the sense having different molarities and different volumes. Okay, right. By using this formula, we can find the molarity of the final solution or resultant solution. M1 V1 plus M2 V2 and so on. Right? V1 plus V2 plus and so on. Resultant molarity. Resultant molarity. But one important point, you have to remember one important point. You should mix two acids. You can mix two bases. Two acids can be mixed, two bases can be mixed, but one acid, one base cannot be mixed. To use this formula, what is the condition? We should mix two similar natured solutions only. For example, this is HCl, this is H2SO4. Yes, you can mix. For example, 0.1 molar HCl, 0.2 molar sulfuric acid. You can mix the two. You will get new acidic solution. To calculate molarity of that acidic solution, you can use this. Or you can mix NaOH and calcium hydroxide, base. Then you can use this. But we should not use this formula when we mix one acid, one base. Another formula is there for that. To calculate molarity, when we mix one acid and one base, another formula is there. When we use M1 V1 plus M2 V2 by V1 plus V2, when we mix two similar natured, two should be acids or two should be bases or two should be neutral solutions. When we mix two similar natured solutions, then only we use this formula. Very, very important point. Above formula is used. The above formula is used when we mix two similar natured solutions. Two similar natured solutions. Solution 1, solution 2. Acid. Yes, you can take base. You can take. One is acid, one is base. You cannot take this. Don't use this formula when we mix one acid and one base. Another formula is that will come after normality concept. So two concepts, dilution principle is over and resultant molarity also over. Any doubt in this, right? Okay. Now you tell me what we did in this small experiment. We added two similar natured solutions, right? Now if we add additionally some x ml of water, we are mixing two solutions and parallelly we are adding some amount of water also. Then how to find the molarity? By changing formula. See, note down that when we add some amount of water, when we add some amount of water, that is some xml. So m resultant is equal to m1v1 plus m2v2 by v1 plus v2 plus x, where x is amount of water added. X is equal to amount of water added. On note, molarity capital M is a temperature dependent concentration term. Units. What is the formula of molarity? Number of moles by volume in liter. So units are mole liter inverse or mole per liter. Mole by liter, right? So mole liter inverse. And these are also very, very important. During numericals you can get the words like decimolar, centimolar, millimolar. Deci means, you know already what is deci? Deci means in physics, you know, basic mathematics. Deci means 0.1 molar. A decimolar solution means the solution whose molarity is 0.1. Decimolar. Centimolar 0.01 molar. Millimolar 0.001 molar or 10 power minus 3 molar. Millimolar solution. Decamolar means 10. Decamolar solution, 10 molar solution. Semimolar means 0.5, half. Semimolar means 0.5 molar. Equivalent weight. I will give you one basic definition to you, then we will continue normality. After completing equivalent weight, we will go with normality. Don't write anything. Sodium hydride, magnesium hydride. Hmm? You know atomic weights, basics? Yes or no? What is sodium atomic weight? 21, 23, 23. Hydrogen atomic weight? 1. 23 grams of sodium is combining with 1 gram of hydrogen. 1 gram of hydrogen. What is the weight of magnesium? Atomic weight? 24. 24. In this compound, what is the weight of hydrogen? For 1 hydrogen, 1. For 2 hydrogens, 2. Now you tell me. 24 grams of hydrogen is combining with 2 grams of hydrogen. Or 2 grams of hydrogen is combining with 24 grams of magnesium. Then 1 gram of hydrogen combines with 12. Half. 2 grams is combining with 24 grams. 1 grams combine with 12 grams. Clear? For 1 gram of hydrogen only we will take standardization. Now coming to the definition, the weight of the substance which combines with 1 gram of hydrogen is called as equivalent weight. The weight of the substance which combines with 1 gram of hydrogen is called as equivalent weight. The amount of substance which combines with 1 gram of hydrogen, standardization, 1 gram of hydrogen is called as equivalent weight. Here how much weight of sodium is combining with 1 gram? So 23 is the equivalent weight of sodium. In this, how much weight of magnesium is combining with 1 gram of hydrogen? 24 only, na? Not 24, 12. 12. Got it? For 1 gram we have to take standardization. 24 grams is combining with 2 grams of hydrogen, but we won't take 2. What we will take for 1 only? So how much weight of magnesium is combining? 1 gram. So what is the equivalent weight here? 12 is the equivalent weight. The weight of the substance which combines with 1 gram of hydrogen is termed as equivalent weight. Write the definition. We never use this definition in any numerical part also, just you forget the definition. Clear? Let us know how to find equivalent weight of acids bases. But you will get one doubt in your mind, what is equivalent weight? I am not getting equivalent weight word, that's why I explained this. Clear? Write the definition and forget, no problem. The amount of substance or the weight of the substance. The weight of the substance. The weight of the substance which combines with 1 gram of hydrogen is called as equivalent weight. Is called as equivalent. EQW2 means equivalent weight. Short form EQWT. Equivalent weight. This is example 1 and this is example 2. Right and just leave it. Okay. For second years, this is the best opportunity. Clear? You are learning basic things very slowly. Once if revision is started in your college, they will go very fast. You cannot cope up with that speed. Akshara meer kuda. Meeku next week exam conduct chestam. I will conduct a test on 3 classes. Okay. Next week exam పెట్టేసుకుందామా? August 15th ఏం కాదు కదా నెక్స్ట్ మనకి. సో నెక్స్ట్ సండే ఎగ్జామ్ పెట్టేసుకుంటా. నెక్స్ట్ సాటర్డే కలిసి వస్తుంది. రైట్. Now let us start equivalent weight of acids, equivalent weight of bases, equivalent weight of salts, oxidizing agent, reducing agent later. Now keep it. equivalent weight of acids. Equivalent weight of acids. Remember the formula, equivalent weight is equal to molecular weight divided by basicity. What is basicity? No, what is basicity? Yeah, I asked basicity. No idea about basicity? Okay, no problem. Shruti? Okay, leave it. But if I ask in future, if you do not say, I'll say. Clear? Now I can accept because you may or may not listen in the first year. But now onwards you should thorough in the basic. Any day, Monday, Tuesday, Wednesday, Thursday, Friday, any day, open the Sunday's class and revise the basics and come. Don't come directly. Clear? Basicity is nothing but the number of H plus ions released by an acid. Number of H plus ions released by an acid. Heading is equivalent weight of acids. So equivalent weight of acid is equal to molecular weight of acid by basicity. Right? Basicity is equal to number of H plus ions released. Number of H plus ions released by an acid. How to know how many H plus ions will released by the acid? Basic equations like dissociation of acids. If you know dissociation of acids, then you can find number of H plus ions. See, HCl dissociates into H plus and Cl minus. How many H plus ions are coming? 1. So basicity is 1. Basicity is 1. And one more important point I wanted to give you right here only, all of you. N factor. N factor. What is another name for the basicity of acid? N factor. How to read this? N factor. Small n factor. N factor. N factor. What is N factor for acids? What is N factor for acids? Number of H plus ions released. What is basicity for acids? Same. Number of H plus ions released. N factor or basicity both are same for acid. Second equation, how sulfuric acid will dissociate? It dissociates into 2H plus and SO4 minus 2. In this case, basicity is equal to 1. Here basicity is equal to 2. H2CO3, carbonic acid. Here also basicity or N factor. Basicity or N factor both are same, right? CO? Tell me. Yeah, okay. Now say loudly because that is mistake now. Can you guess basicity for this?
-1 for oxy acids. Basicity is equal to oxygens.
Yes, number of oxygens -1. For this, basicity is different. Clear? For normal acids, you can follow these equations, right? Or just you see the formula of the acid. In the acid formula, how many hydrogens are present? That number of hydrogens is the basicity. You no need to dissociate. Here, how many hydrogens are there? 2. So basicity is 2. Basicity is 1. For these acids like HNO3, HCl, HNO2, but only one particular acid is there, that is oxyacid of phosphorus. In that case, you have different formula for basicity. Clear? Keep heading. Basicity of oxyacids of phosphorus. Basicity of oxyacids of phosphorus. basicity of oxyacids of phosphorus. What is the meaning of oxyacid? See, HCl is a normal acid without oxygen. Normal acid. If oxygen is present in the acid, that is called as oxyacid. Oxyacid, because oxygen is present. That's why this acid is called as oxyacid. Oxyacid. Acid with oxygen is called oxyacid. This is not oxyacid. Oxyacid. Oxyacid of which element? Sulfur. Now you tell me, second one is oxyacid or not? Oxyacid only. Oxygen is present, but oxyacid of what? Phosphorus. Oxyacid of sulfur, oxyacid of phosphorus. Oxyacid of phosphorus. This is oxyacid of sulfur atom. In case of oxyacids of phosphorus, basicity is equal to number of oxygens minus 1. Number of oxygens minus 1. Number of oxygens minus 1. Let us see this example. H3PO2, H3PO3, H3PO4. Basicity. What is another name for basicity? N factor. Basicity or N factor is equal to, tell me, how many oxygens are present in this? 2 oxygens. 2 minus 1. So basicity is 1. Don't take 3. If you take 3 basicity, you will get wrong answer. Some students will think that 3 hydrogens are present, so basicity is 3. That is wrong. Clear? In which case? In oxyacids of phosphorus. In other cases, you can take directly. For second one, basicity, number of oxygens are 3 minus 1. So basicity is 2. Here 4 minus 1 basicity. Here number of hydrogens is equal to basicity. For last one, okay, you can take directly. But for these two, follow the formula. For last one also, we should follow the formula only. Clear? Only one exceptional case. In case of oxyacids of phosphorus, use this formula to find basicity. What is the necessity to learn about basicity? In ionic equilibrium, questions depends on basicity concept. Ionic equilibrium chapter, first year physical. In solutions chapter, first part numericals based on all these topics only, like normality, equivalent weight concept, basicity, everything. Right. Okay, what is the basic formula of equivalent weight of acids? Fundamental formula. Equivalent weight is equal to molecular weight of the acid by basicity. What is basicity? In general, number of H plus ions released in general. But for oxyacids of phosphorus, basicity is equal to number of oxygen atoms minus 1. Number of oxygens minus 1. You know molecular weights of some important acids? Don't know, right? One important compound, sulfuric acid. Note on molecular weight. H2SO4 molecular weight is equal to 98. HCl molecular weight 36.5. Note down these two. At least these two. But you have to by heart molecular weights. Let us do one question. Equivalent weight of H2SO4 is very simple. Tell me, what is the formula of equivalent weight? Molecular weight divided by basicity. Molecular weight is 98 by basicity of sulfuric acid 2. How many H plus ions it gives? 2. So 49 is the equivalent weight. We use this equivalent weight in normality numericals. Another concentration term is there, na? Normality. Okay. Note down this question. If M is the molecular weight of H3PO3, then equivalent weight of H3PO3 is equivalent weight of H3PO3 is option A m by 1, m by 3, m by 2, m by 4. What is the formula of equivalent weight? Molecular weight by basicity. But in case of oxyacids of phosphorus, basicity is equal to number of oxygens minus 1. Number of oxygens are 3. 3 minus 1, m by 2. M is given in the question only. If m is the molecular weight. Okay, note down the solution. What is equivalent weight of acids? Molecular weight by basicity. Next key weighting. Equivalent weight of bases. Equivalent weight of bases. Equivalent weight of bases. Equivalent weight is equal to molecular weight of base by acidity. What is acidity? Acidity are also called as N factor. For acids, we used same symbol only, N only. For bases also we are using same symbol only. Clear? Acidity, number of OH minus ions released. Number of OH minus ions released by a base. Number of OH minus ions released by a base is called as acidity. Note down some important bases. NaOH. NaOH gives rise to Na plus and OH minus. How many OH minus ions are releasing? 1. So acidity is equal to 1 or N factor is equal to 1. Magnesium hydroxide. Magnesium plus 2 plus 2 OH. Dissociation is important. Acidity is equal to 2. Okay. Calcium hydroxide. Ca plus 2 plus 2 OH minus. You learn these three. Three are important. Magnesium hydroxide, calcium hydroxide. Acidity of base. Number of OH minus ions released. Okay. Note down the formulas and learn by next week. Okay, I'll give you normality all the formulas. Note down all the formulas. How many concentration terms were finished? 4. Weight percent, weight volume, molarity, normality. Note down all the formulas. Normality is equal to GEN by volume in liter. What is GEN? GEN stands for number of gram equivalents. Number of gram equivalents. Sorry. Number of gram equivalents. How to read this? GEN, number of gram equivalents. Don't read like this. Gram equivalent number. Gram equivalent number is not correct. Number of gram equivalents. GEN, like number of moles. Like number of moles. One important formula, GEN is equal to N into V. Very, very important. Keep symbol very, very, very important. What is the expression for GEN? Normality into volume in liters. Normality into volume in liters. Okay, see all the formulas of normality. First formula, normality is equal to number of gram equivalents by volume in liter. GEN, how to read GEN? Number of gram equivalents. Number of gram equivalents is equal to normality into volume. Very, very important. Second formula, normality is equal to weight by gram equivalent weight into 1000 by volume in liter. You know how to find gram equivalent weight? Just now I finished for acids basis. And write third formula, normality is equal to weight percent into 10 into density by gram equivalent weight. See, in normality gram equivalent weight is coming, but we already finished gram equivalent weight calculations. Fourth one, N1V1 is equal to N2V2. When we use this N1V1 is equal to N2V2, tell me. Dilution principle. Like M1V1 is equal to M2V2. N1V1 is equal to N2V2. Resultant normality, N resultant is equal to N1V1 plus N2V2 divided by V1 plus V2. See, if you thorough in all these, you can understand first lesson of physical chemistry easily. First part is this only, like weight percent, volume percent, normality, molarity. Solutions chapter, 30% part is concentration terms only. You are finishing that 30% part. Remaining 70% is new Henry's law, Raoult's law, colligative properties. 30% is concentration term only. Next, relation between normality and molarity. Relation between normality and molarity. Normality is equal to N factor into molarity. This is also important relation. Normality is equal to N factor into molarity. You know what is N factor? You know N factor. N factor nothing but basicity in case of acids, acidity in case of bases. Already we finished N factor concept also. N factor is nothing but basicity in case of acids. N factor is nothing but acidity in case of bases. See, if we know molarity, you can find normality by using this relation. N factor nothing but basicity. Basicity means number of H plus ions released. N factor nothing but acidity. Acidity nothing but number of OH minus ions released. Clear? And you know this, what is deci? Deci means 0.1 decimolar. 0.1 molar. Similarly, decinormal means decinormal. Now tell me, decinormal solution means 0.1 normal, decinormal. Centinormal solution means 0.01 normal, millinormal. Similar to molarity. Millinormal means 0.001 normal. Clear?